Chapter 7, we are only covering the section 7.2, what is energy? Energy measures the ability for things to change themselves or to cause change in other things. So here we're looking at energy, and we're looking at changing things. Examples are changes in temperature. So you get hot, cold, speed, you go slow, fast, position, you're moving from point A to point B. Pressure, think of a balloon. You can increase pressure, cause it to pop, decrease, it deflates, or any other physical variable. Physical key thing is what we're looking at here. So energy is causing something to change. You're adding energy or taking away energy to cause some of these changes. There are 6 main forms of energy: mechanical, thermal, chemical, electromagnetic, nuclear, and electrical. Out of these forms of energy, there are sources of energy, which there is a difference. Forms of energy are the types. The sources, how do we make energy? Where does the energy come from? We have hydroelectric, hydro meaning water. Think about the Hoover Dam, uses the water to create the electricity. Solar energy, you have solar panels. From the sun, you collect the energy. Geothermal, geo is earth. So we get heat from the earth. And biomass, bio is life. So you basically have the breaking down of the decomposition of living matter that creates energy. And you have hydrogen fuel cells and wind. Obviously wind, you'll see a lot of turbines and windmills kind of things put up to collect the energy is a new kind of thing that we see a lot of going up now. You will see these referred to in an activity in class that we did with the energy roundup, and we'll be revisiting back to these as we go throughout the physics unit. When we're talking about energy, we talked about units that they're measured in. Earlier we talked about the metric system. We talked about grams, liters, and meters as our main base units. Here we're looking at energy. So pushing a 1 kilogram object with a force of 1 Newton for a distance of 1 meter uses 1 joule of energy. So joule is our unit that we use to measure energy. So when you solve for energy problems, you're going to use the capital J as your unit to measure those. So here the picture shows you that for 1 joule means that 1 Newton, and that's the amount of force that is being applied to the cart, and the cart's mass is 1 kilogram. So 1 Newton moves the 1 kilogram cart 1 meter, and this is your distance. So that is our basis for what a joule is. 1 joule. You double that, you need 2 joules. Okay, so that is the relationship that we need to understand. Although 1 joule is a very small amount of energy, okay, 100 watt light bulb uses 100 joules of energy every second. Okay, so it's a very small amount, and you're going to see that here. 1 joule is equivalent to 1 kilogram multiplied by your meter squared over your seconds time squared, which seconds is your time. Okay, so you have your joule and your Newton working together here to get your amount of energy. One of the forms of energy is the mechanical energy that we talked about. This is the energy possessed by an object due to its motion or position. Okay, so position means where it is sitting. Where is it placed? Motion, obviously, it's movement. Potential energy and kinetic energy are both forms of mechanical energy. So mechanical energy can be either or. So in position 1, when you look here, you have potential energy because the position of the ball is at the top, so your potential energy is very high. But as the ball moves down the ramp, the potential energy goes down and the kinetic energy goes up. And we'll get into that later. And then at the bottom, you'll see that it's a constant transition. You go back up to potential energy. So as it goes down and then it goes back up and then it goes back down again. So as you go to roller coaster, you have a constant exchange of the energy from going potential to kinetic. Electrical energy comes from the electric charge, which is one of the fundamental properties of all matter. Some things carry a charge better than others, and we're going to talk about that in chapter 16 with electricity a little bit more. Because obviously, in order to light a light bulb, you have to have energy. Where does that energy come from? Well, you use a battery. It comes from chemical energy that gets converted into light energy. And some instances, light bulbs will also give off heat energy, some more than others. And then you have your electrical energy. The electromagnetic spectrum. This includes the visible light infrared radiation, which is heat, and the ultraviolet light, the UV light. And the UV light is the light that is not good for us. Okay. Light energy and heat energy are included in the electromagnetic spectrum. Now notice that this is the only part of the electromagnetic spectrum that is visible to us, which is the rainbow. All the other parts of the electromagnetic spectrum exist, we just can't visibly see them. But we know that there is the energy there because you can measure the movement of the energy particles. Chemical energy is a form of energy stored in molecules. Batteries are a good example of stored chemical energy. You'll see an example of this everywhere, and as you look, there's different size batteries. You can go even larger than D. That the bigger they are, the more energy that they carry. So this is basically potential energy in the batteries to be converted into kinetic energy when needed. Elastic energy is energy that is stored or released when an object changes shape or deforms. A lot of you have seen, reference rubber bands. When a rubber band is stretched, it changes shape. That's elastic energy. Same thing with the bow and arrow. Okay. Rubber bands, springs, archery bows. You have your stress balls, balloons, all those kinds of things that you can talk about with elastic energy. Nuclear energy is a form of energy stored in the nuclei of atoms. In the sun, nuclear energy is transformed to heat that eventually escapes the sun as radiant energy. So radiant energy is your heat that we get from the sun due to nuclear energy of the nuclei atoms releasing it through the process in the sun. It's a big ball of energy. Without the sun's energy, though, the Earth would be a cold, icy place with a temperature of negative 273 degrees. Obviously not hospitable by anything at that degree. So the warming of the planet is necessary for the sun to provide us energy to drive the entire food chain. So you have your energy coming down from the sun that makes the plants grow, that the animals eat, that rely on them, and also provide the weather. The weather is key because it provides us with rain to make the plants grow. And without that, your cycle will stop. All objects with a mass feel forces in the presence of Earth's gravity. These forces are a source of energy for objects or moving matter, such as falling rocks and falling water. So gravity plays a big key in the energy. So in physics, the word work has a very specific meaning. Work is a transfer of energy that results from applying a force over a distance. So to know how much work is done, you need to know the distance and the force in order to solve that. And we will look at this a little bit later in more detail. Okay.